Imagine your regular EVM wallet gaining the ability to split bills, pay itself, and recover from lost keys, but only when needed. That's possible with EIP-7702. So, in this video, we will learn about EIP-7702 and we will see how we can achieve ERC20 gas sponsorship with EIP-7702 on Berachain with the help of a demo app. So, without any ado, let's jump into it. Before EIP-7702, Ethereum or EVM chain users faced a fundamental dilemma with their wallets. Traditional Ethereum wallets called externally owned accounts or EOAs worked like digital safes with only one key. If you lost that key, you lost everything. No recovery option, no second chances. These basic wallets created three major pain points that prevented mainstream adoption. First, every action required a separate transaction with its own gas fees. Imagine having to pay a processing fees twice just to buy coffee because you needed to first authorize your card, then actually make the purchase. Second, users always needed to hold ETH for gas fees, creating a chicken and egg problem for newcomers who wanted to use their own tokens but couldn't without first acquiring ETH. Third, the constant fear of losing access haunted users, as one misplaced seed phrase meant permanent loss of all their assets. So in 2021, Ethereum community proposed EIP 4337, which introduced the concept of account abstraction, a way to give wallets programmable superpowers. Think of it as upgrading from a basic flip phone to a smartphone. However, this solution introduced its own complexity maze. Users had to abandon their pre-existing wallets and migrate to a smart contract wallet or address. Imagine you being told that you need to move to a new email address for better features. The system required entirely new infrastructure layer with specialized actors called bundlers and paymasters, creating a parallel transaction system alongside regular Ethereum. On top of that, the smart contract transactions cost twice as much in gas fees. The adoption barriers proved significant. Then, in the May of 2024, Vitalik Buterin, the co-founder of Ethereum, proposed an elegant solution to this, EIP-7702, with the main motive that what if your regular wallets could temporarily borrow some smart contract superpowers just for a single transaction. Here's how it works conceptually. When you want to use advanced features, your regular wallet temporarily delegates its execution to a smart contract. During the transaction, you get access to all the smart contract capabilities, batching multiple operations, having someone else to pay your gas fees, or using advanced security features within your EOA wallet. Once the transaction is completed, your wallet returns to normal state. With this, your address remains same, your assets don't move, you maintain full control throughout. This approach eliminates the adoption barriers of 4337. Users keep their existing wallet addresses, no migration required. So EIP-7702 or Ethereum Improvement Proposal 7702 was accepted in the Pectra upgrade of the Ethereum mainnet. Here are some key features that EIP-7702 enables. The first one is transaction batching. Transaction batching transforms multi-step operations into one single action. Instead of approving a token and then swapping it into two separate transactions, users can do both in one atomic operation. Another one is gas sponsorship. Gas sponsorship revolutionizes user onboarding. A lot of chains offer gas sponsorship to newcomers or new users to deploy their contracts on that chain. But in those cases, they manually transfer gas tokens to those users' wallets. But with EIP-7702, applications can pay transaction fees on behalf of users, removing the biggest barrier for newcomers. For example, gaming platform can let users start immediately without acquiring ETH first, and that platform can handle or sponsor the gas for its users. Another one is session keys, which brings Web2-like experiences to Web3. For example, a user can grant temporary and limited access to an application where the application can spend 10 tokens of the user over the period of 24 hours without the application asking for approval for each purchase. That's possible with EIP-7702. And then another key feature that can be enabled with EIP-7702 is social recovery. Users can set up recovery mechanisms using trusted contacts, hardware devices, or service providers. Lose your keys? No problem. You can have a smart contract functionality recover your key or recover your assets. So the possibilities are endless. Whatever you can do with smart contracts or with a single smart contract function, you would be able to do with EIP-7702 by delegating that smart contracts functionality to your own EOA address for a particular transaction. So now let's understand the use case of gas sponsorship by seeing ERC20 gas sponsorship with EIP-7702 on Berachain blockchain. But before that, let's understand a little bit about Berachain. So Berachain is a EVM identical layer 1 blockchain with a novel proof of liquidity consensus mechanism, aligning security and liquidity at the network level. So some of the key features of Berachain are, first one, obviously the proof of liquidity novel consensus mechanism, where instead of locking tokens like traditional proof of stake consensus mechanisms, users can stake their tokens while still keeping them available for DeFi protocols, solving the token lockup problem. Another one is that it's EVM identical, which means that it's fully compatible with all the EVM opcodes and ERCs which are already implemented, which also means that all the Ethereum applications will be compatible with Berachain. Since the EIP-7702 was implemented in Spectra upgrade of Ethereum and Berachain is EVM identical, EIP-7702 was implemented on Berachain in their Spectra upgrade, which is very identical to Spectra upgrade. Another feature is the tri-token system. Bera for gas fees, BGT for governance, and Honey, which is a USD pegged stablecoin. Another feature is strong community support. 48.9% of the 5 million Genesis Bera supply was allocated to community initiatives, demonstrating the commitment to decentralized growth. Now let's come back to our app. So we will be building this app where we will have the EOA account and the sponsor account. So the EOA account will send few Bera tokens to a third address and they'll sign the message and pass it on to the sponsor account. The sponsor account will then execute that transaction by paying the gas fee. And the EOA account will transfer 1 Honey token per transaction to the sponsor account for paying the gas fee. So in this case, the EOA won't need Bera for gas. They'll just need Bera for sending the transaction, and the sponsor account will get Honey token for executing the transaction. So now let's understand the files of the app, where the first thing what we will see is the contract and the Foundry app. So we will need to create a contract to which our EOA can delegate to, which means that our EOA will get that contract's ability, which will help us do ERC20 gas sponsorship operation. So now let's look at our contract. So this is how our setup would look like. We will have two apps. One will be under contracts, which is a Foundry app. Another will be under front end, which will be a React White TS app. So under contracts, we have the smart contract along with the deploy script, just like we have in the Foundry app. So we have two environment variables. We have one environment variable over here. We have another environment variable in the front-end app. So for the environment variable in the Foundry app, you will need two things. You'll need a Berachain RPC URL and a private key to deploy the smart contract. So over here, we will be doing everything on the Berachain Bipolia testnet. So you'll need a Berachain Bipolia testnet from QuickNode over here. To get the RPC, you can basically go to quicknode.com, create an account, and then go to the endpoint section of your account or dashboard, and then create a Berachain Bipolia RPC URL. So it will look something like this. You can go to the RPC or RPC endpoint, then click on this button to copy the HTTPS URL from here, which you can paste in this environment variable by replacing this, along with this environment variable by replacing this. So this entire code base will be linked in the description below. So don't worry about that part. And this will be the private key, which you'll need to deploy the smart contract. Please use the demo private key or the wallet where you do not have real funds or all the funds, because having a private key in an environment variable is not always ideal. And if you have it in the environment variable, please make sure that you never push it to a public domain like GitHub or any code sharing platform. Now let's look at our smart contract. So this is our smart contract, where first we are of course declaring the license, then declaring the Solidity version, then importing few OpenZeppelin libraries over here, which we also installed and added the remapping over here. And you can see we have installed the OpenZeppelin contracts library using Forge install. Then we are initializing the contract with the retency protection by inheriting retency guard. Then we have this definition, which lets us call library functions on byte 32. Then we have two constants. One is the honey token and other is how much honey token we want to send to the sponsor per transaction. So this is a mock honey token, which I have deployed, a basic ERC20 token, which I have deployed on the Bipolia testnet. Then we have the mapping, which will be used to map the nonce numbers to true or false. Then we have some error messages over here. Then we have the event over here and a struct. So we are defining this struct for grouping custom related data types. Then we are defining our actual execute function with these data sets, and we are calling it to be payable because it will receive honey. Then we are verifying the signature, which we get from the EOA who signs the initial transaction. And then we are adding Ethereum prefix to the signature and getting the address from the signature, address of the EOA from the signature. And then we are making sure that if the EOA is the signer or not. Then we are checking the nonce over here so that a previously signed transaction or sent transaction cannot be sent again. We check if the nonce has been previously used or not. If it has been used, we mark it as used. Then we check if the EOA has sufficient ETH to send or not. And then we initialize the IERC20 interface and check if the EOA has enough honey to pay or not. Then we actually transfer the honey to the sponsor, exactly one honey to sponsor, which is the payment for the gas fee to the sponsor. And then we execute the call where we send the Berachain token, some Berachain tokens from the EOA wallet to the third wallet, the gas for which will be paid by the sponsor. And we return the ETH to the sponsor again, whichever amount of ETH is left out after the gas is paid, and then emit the transaction sponsored event. And then we have all the function, a function for batch transaction, the function to get the nonce, the function to check if the nonce has been used, a function to get EOA's honey balance, a function to get EOA's ETH balance because EOA sends some ETH to third party, a function to check if the sender is approved or not. This always returns true and checks for backward compatibility with front end. And then this receive function, which is called when the contract receives Berachain token. Now this is the smart contract using which our EOA can send some Berachain tokens to a third party address, and the gas for that transaction will be paid by the sponsor account, and for that our EOA account will send a honey token to the sponsor account as a compensation for the gas. Now the thing is that since we want to show EIP-7702, that functionality of the smart contract will be performed by our EOA account itself. So our EOA account itself will act as a smart contract in this case. Now let's look at our front-end code. So in our front-end code, the first thing we will look at are configuration and build files. So the configuration files, we have package.json, we have tailwheel config file, we have the ts config file, we have white config, which is used for white bundler configuration and enables a plugin for JSX transformation. Then the ts config file has the TypeScript setting for our main app and the node app. Then the tailwind config file basically extends the application with Berachain specific colors, which you can see in our application over here. Then comes the core application files and styling. So in our core application file, you will see under source app.tsx, which is our core application, and main.tsx, which extends the app, which is our core application file. Then some styling in index.css, where we basically import Tailwind CSS, has dark theme defaults, and then has custom theme or custom colors for the scroll bar. Coming back to our core application file, we are importing a bunch of stuff like React, ethers, toast library for our notification toast within the app, some components over here which we will understand about later, and a config file which also we will understand about later, Lucid React for custom icons, in this case a breaker towards the bottom, and we are exporting the account interface, which you can see this is it, but the functionality of it comes from account switcher component, which we will understand about later in the video as we go file by file. So first thing, we have some state management over here. We have the state management for provider, accounts, current account, loading, set loading, etc. Then we basically have the provider initialization over here. We are loading the RPC URL, we are verifying the connection, and then we are loading the accounts from environment variables, where in this environment variable, we first have the QuickNode RPC URL again. And once we deploy the Foundry contract, this will be replaced by the Foundry contract's address, and then this will be the EOAs private key, this will be the sponsor private key. In the contracts directory, we have few scripts already in the package.json file, where if you just run npm run deploy, it will run this command, which is forge script deploy .sol rpc url bipolia broadcast. So it will deploy that smart contract. And the deployment script is basically just a very simple boilerplate deployment script where we get the private key and have some console messages during the deployment phase. And in foundry.toml, the Foundry config file, we are already getting the white RPC URL from our environment variable and setting it as bipolia variable. So that's why you can see in the deployment script for script deploy.s.sol, we have the RPC URL as bipolia. So you just basically have to run npm run deploy and it will deploy the smart contract. So first you have to cd into the contracts directory, then run npm run deploy, and it will start to deploy the contract. First it will build and compile the contract and then deploy the contract. So as you can see, the transaction has been sent. It's waiting for it to get confirmed, and it's confirmed. So you just need to get this hash, and in the front end environment variable, replace this with this hash. Now, coming back to our app.tsx, the next thing we are doing is getting the accounts or loading the accounts from the private keys. We are loading the EOA and sponsor account from the private key. We are checking if they exist or not. We load the balances of both the accounts. We load the native token balance, which is Bera token balance, along with the honey token balance. Then we load the same for sponsor and then change the state variables for them. Then we basically have the function to get the honey token balance, which we used over here to get honey token balances for EOA and sponsor account. And we have one function to refresh balance. So you must have seen we have this refresh balance button over here, which if clicked refreshes the balance. Then while the app is loading, where in the initial phase, if you reload the app, so in the initial phase, once the app is not 100% loaded, we will show this message. So it will be done by this, where if loading is set true, then return this, which is just a div with a message loading Berachain bipolia, basically the app. And then we have the app structure over here, where we have the toaster, which is the notification toast which comes after each operation. Then we have the actual app over here. You can see the header is defined over here, which you can see over here. and then a paragraph tag under the header, which is this. And after that, we have the account switcher component, which is this part over here. And then we have the sponsorship demo component, which comes from the sponsorship demo component, which we will understand about in a minute. And then the footer. So this is our app.tsx core file. And then the main file, which is the entry point of our app, which basically loads the app.tsx, and app.tsx basically loads the components, account switcher, sponsorship demo, along with some skeleton. Now, before looking at our components, let's look at some library files. So we have two library files over here. One is config.ts and another one is EIP-7702.ts. In config.ts, we have network configuration along with the implementation contract and the honey token contract. Then we have some EIP-7702 constants like the transaction type, the delegation prefix, the gas per auth, empty account gas, domain separator, etc. Then after that, we have the ABI for the honey sponsor contract, which we just deployed. So we have the ABI for that in the config.ts file as well. And then in EIP-7702.ts, we have the core EIP-7702 functionality, where the main function is this, where we check if the EOA has the delegated contract code or not, and also extract the implementation address. So that is what we are doing over here. We check if the EOA has the code or not, and then extract the address as well. And then another important helper function in this is sign sponsorship message, which creates a message digest expected by the smart contract function, which will be EOA's smart contract function. And then we sign the message, and then we estimate gas using this function. We check authorization using this function, and then we are exporting them as interfaces. We are exporting the transaction interface and authorization interface, which will be used in the components. And finally comes the most important components files. So we have three components over here. One is the account switcher component. Another is the sponsorship demo component, which is our main component, which performs all the function. Another is transaction status component. So let's go one by one. Let's first understand account switcher and transaction status component, and then understand sponsorship demo component. So this component basically is used for switching between the accounts. So the switching logic is handled over here. You can see that on click on switch. So it checks that what's the account which is currently selected and switches the logic or the display based on that. And it shows which account is selected. It shows formatted address, shows formatted balances, and we display all of that. Now let's look at the transaction status component, where we will have three kinds of transaction statuses: pending, success, and error. And then based on that, we will have different kinds of color. We will have a function to actually get those colors for each, and then the actual structure of the transaction status box, which will appear after each transaction is sent. And you can see that we have also exported this interface. Then comes our main component, sponsorship demo component, where first we have our import statements for various libraries like React, Ethers. We are importing the account interface from our main core app file. We are importing the config from config file. We are importing few things from EIP-7702 file as well. Then we are importing the transaction status from the transaction status component. And we have few TypeScript interfaces over here, where txStatus will track the transaction status through multiple steps. Then we have the function sponsorship demo, where we first have component state management over here. We are getting the implementation contracts addresses. We are getting the EOA address, the sponsorship account address. Then we are checking the delegation status, if the EOA has delegated to smart contract or not. This is run when the component is mount or EOA address changes. We basically check if the EOA has the EIP-7702 delegated contract code or not. And then we have a function to update transaction status. Then we have the setup delegation function, which is one of the major function of this file, where in the first step we are checking the honey balance. In the second step we are checking if the delegation already exists or not, and if the current delegation is delegated, check if the implementation is correct or not, and if it's not delegated, set up the delegation, create the authorization for the delegation, send EIP-7702 transaction to set up or establish delegation, where we send the transaction, get the receipt, and then update the status. And then we send a toast message, which is the notification toast. Then we have the most important function, perform gas sponsored transaction, which actually performs the sponsored gas transaction, where first we check balances, where we check honey balance, we check Bera balance, and then print the messages according to that. Then we prepare the sponsored transaction, get the current nonce of the EOA over here. Then we are setting up the transfer call where the recipient address is hard coded over here, or we can even get it from environment variables. We can set it up as an environment variable or hard code it here. So since we do not have it in environment variable, we will get it from here. And then get the nonce and set the nonce in nonce to use variable for the EOA address. And we are initializing the contract over here with the implementation address, the ABI, and the provider, which is QuickNode in this case. Then we are checking if the nonce is already used or not, where we have a while loop continuously going on for 10 attempts. And if the nonce is found to be unused, we can break from the loop, and if it's found to be used, we print the error message and increment the nonce. Then after that, we are signing the sponsorship message, and before creating the transaction, we are verifying few things and printing them to console. We are verifying if the EOA has honey balance or not. We are verifying the transaction details. We are verifying the recipient sponsor address. We are verifying the nonce, chain ID, all of that stuff. And then we verify the signature locally, and then based on that have few other console messages over here. And then we are encoding the transaction function call using the specific function signature to avoid ambiguity and packing all the parameters correctly. And then in the third step, we will actually send the transaction where we will update the status as broadcasting. We will get the sponsor nonce, we will get the fee data, and then print few messages over here. Then we will extract the address of the delegated EOA and again print few messages. We will first try to simulate the transaction and then catch any errors if there are any. And then this is the transaction body. This will be the transaction body, and we will finally send the transaction. Then we will wait for the receipt and refresh the balances and catch any errors if there are any, and then set the is processing to false. Then after that, we have the UI rendering for everything. We have the transaction flow visualization, we have all the components, we have the action panel. Everything which you see over here is getting rendered from here. So this is how the code base of our app looks like. And the first step in the app is to delegate. But since I have already delegated this shows delegation complete. But let me quickly get a new wallet address to show you what this step looks like. Alright, so I have set up a new EOA. So you can see this is a new address. This one has 100 honey token, which is a mock honey token I have deployed on Berachain Bipolia. It has 1.99 Bera, and the sponsor account has 108 honey at this moment and 0.48 Bera. So in the EOA section, you can set up the delegation and then send the sponsor transaction where the sponsor account will be sending the transaction. And in the sponsor account, we just have one button to check the honey balance. So you can see this is the toast. Now let's come back. Let's set up the delegation first. You can see that the delegation status right now is not delegated. This is our smart contract address. So let's delegate. So it will send a transaction and delegate the smart contract. So you can see that it has been delegated now. This is the transaction status box. So based on the status of the transaction, the color of this box changes. So as you can see, the transaction was successful. So the color of this box is green now. And now let's send the sponsor transaction. So let's send. So you can see this one has 100 honey token. This one has 108 honey token, 1.9 Bera, 0.48 Bera. So the transaction has been broadcasted, and you can see the honey balance has been updated from 100 to 99 for EOA and from 108 to 109 for sponsor. And now let's look at the transaction in Beratrail. So you can see that this was our sponsor address ending with 9A6. You can see ending with 9A6. This was our sponsored address. This one executed the transaction. That is why the from address is this. And our EOA, which ends with 1102, actually acted as a smart contract, which you can confirm by this symbol over here. So what happened is 0.0010 Bera got transferred from our EOA address, which is this, to a third address which we hard coded, and one honey token was transferred from our EOA address to our sponsor address. And you can see that the from field is our sponsor address because it actually executed the transaction. But the magical part is everything got facilitated by our EOA address itself, who wanted to send the main transaction sponsored by our sponsor wallet over here. So our EOA itself acted as a smart contract in this case. So this is how you can achieve ERC20 gas sponsorship using EIP-7702 on Berachain. So hope you learned something from this video. Hope you found this application interesting, or this demo application interesting. The code for the entire application will be linked in the description below, and I'll see you in the next one. Bye bye.